Hi students. In this session we are going to discuss about oscillator. What is oscillator? Oscillators are device used to produce a periodic electronic signal. We know that is effect of feedback. Already in the last session we have discussed about the effects of feedback in the amplifier. So we already know uh, amplifier with positive feedback used as a oscillator. What's the difference between amplifier and oscillator? In amplifier, there is a need of input signal, and oscillator, there is no need of input signal. Without applying input signal, it generates a continuous periodic signal using the bias voltage applied to the circuit. So that is bias voltage is nothing but a DC supply voltage. So if you are giving a DC supply voltage, so it will generate a periodic electronic signal. It may be either a sine wave, a square wave, or any sawtooth wave, any kind of wave. We will see next. So what is the condition for oscillation? We know the amplifier with positive feedback is used as a oscillator. What is the gain equation for the positive feedback amplifier? The gain equation equal is A by 1 minus A beta. We already know this equation explanation and everything we derived in the last session. So this is a gain of positive feedback amplifier. A positive feedback amplifier is used as an oscillator. So what is the condition for oscillation? In 1921, a German scientist, Farkaschen, his name Farkaschen, he created a condition to act as amplifier, act as an oscillator. Name Farkaschen. So that's why this criteria is called Farkaschen criteria. What are the criteria? Two criteria are available. The phase shift around the loop is 0 degree, or else the total phase shift is 360 degree. Then the closed loop gain value is equal to 1. What is closed loop gain value? Beta A value equal to 1. This is the two condition for oscillation. See here, we apply the second condition, beta. These are the two necessary conditions. The amplifier acting as a oscillator. Take beta A equal to 1. If you are applying beta A value equal to 1, that is 1 minus 1 equal to 0. That is A by 0. Anything by 0 value is infinitive. So the gain value is infinitive. What is the actual formula for gain? A equal to V out by V in. So if you are V out by 0, if you are indirectly writing V out by 0 equal to infinitive. So without any input, it produces the input voltage gain. So that is the condition for oscillation. So a positive feedback amplifier is used as a oscillator. Then why we need an oscillator converter DC signal to AC signal? Why we need an oscillator? To generate a continuous periodic signal, we need an oscillator. What are the application of oscillator? The oscillators are used in many simple, smaller application, like from watch to calculators, computer, and it used in many places. These are the application of oscillator. Then we will see the block diagram of an oscillator. So in an electronic amplifier circuit, we will take some part of the output and fed back to the input. That is feedback. That is positive feedback network. That is fed back to the input. So this is a frequency determining element. Actually here the feedback is added with the input signal. So we will get the output in the this side. So this is a simple black diagram of a oscillator. Next, so these kind of, it will generate this is called undamped oscillation without ending. So this is called oscillation. At the closed loop gain value is greater than 1, that time the oscillation is initiated. If the closed loop gain value is equal to 1, that oscillated signal will be generated. This is a working. So amplifier is that this amplifier has the gain of AV. Then that here the application of DC voltage, okay, for this amplifier. Then a part of without giving any input, we are not giving any input, just we are applying the DC bias voltage. That bias voltage applied to the amplifier, so it generates some output. That output is fed back to the input. Then because of the feedback, so it will generate some kind of oscillation. So see here, at a time t naught, the oscillation, that at that time the closed loop gain value is greater than or equal to 1. That time the oscillation gets started. At the time the closed loop equal to 1, the oscillation is produced. This is about the working of oscillator. Next, in our syllabus we are having the crystal oscillator. Under oscillator we are having crystal oscillator. So this is a real image of how the crystal oscillator looks like as a hardware. These are the sample crystal oscillator for your reference. Then if you are opening the top, these are the available component inside the crystal oscillator: positive pin, resistor, capacitor, output pin, then disable pin. This is a crystal. Then IC die and ground pin. These are the things available inside the crystal oscillator. Just for your reference, I showed this one. Actually, in our syllabus, we are having a working of a crystal oscillator. We will see this is a normal crystal, a quartz crystal. Then how this will be fitted in the circuit. So a slice of the crystal is cut from this quartz crystal. This is a electronic electrodes. These are the electrodes connected with that. So this is what we have to use inside the circuits. This is a symbol of a crystal oscillator. A crystal is available. So inside that, electrodes and leads are connected here. So electrodes and two leads are connected here. This is a symbol of crystal oscillator. Then crystal oscillator equivalent circuit. This is a crystal oscillator equivalent circuit. How the crystal actually really working? It's look like it's working as a RLC circuit. RLC. This is a working as a RLC circuit. So how the really this RLC circuit is working? That's what the crystal oscillator is working. These are the equivalent circuit components. Actually, the crystal oscillator working in two frequencies: series resonance frequency and parallel resonance frequency. This is the formula for series resonance frequency: Fs. Fs equal to 1 by 2 pi root of Ls into Cs. Parallel resonance frequencies we can written as Fp equal to 1 by, simply we can write 1 by 2 pi root of Ls Cs Cp divided by Cs plus Cp. This is the formula for parallel resonance frequency. Then I will explain how during series resonance frequency, how the circuits will look like, and parallel resonance frequency, how the circuits will look like. This is a circuit diagram, crystal oscillator diagram for working in a series. This is series resonance frequency. This part is series resonance frequency. This is parallel resonance frequency. Okay, see here, what are the components available here? The important component here is RFC, that is radio frequency coil. It provides two functions. It provides DC bias to the circuit, and also it make the output is free from AC signal, not affected by the AC signal. It provides two usage. And we are coming to the R1, R2. This is acting as a voltage divider network. And if you are coming to the RE, that RE, here also RE is there, RE. RE stabilizes the circuit. And in a series resonance circuit, emitter capacitor is there. This capacitor acting as a AC bypass capacitor. Okay. Then here two capacitors were there in a parallel resonance, C1 and C2. This is acting as a capacitive voltage divider network. Okay. In a series resonance circuit, another capacitor is a coupling capacitor. That capacitor blocks the DC signal, that is a propagation from base to collector. Okay, this is what you have to know about the crystal oscillator. That's it. This is about a crystal oscillator and working of the component available inside the crystal oscillator. Okay, thank you guys. A summary of this class. In this class, we discussed about the oscillator and types of oscillators. So many types of oscillators were there. LC oscillator, RC oscillator, Colpitt's oscillator, Hartley oscillator. But in our syllabus, we are having only crystal oscillator. Crystal oscillator is a high stable, high frequency stability oscillator. Okay. I hope everyone understand this working of oscillator and crystal oscillator. We will see in the next session. We will discuss about the UJT relaxation oscillator and IC 555 timer. Thank you guys.